Today is February the 15th, 2018, and I had to pull this amplifier off my working shelf. This is one I listen to just about all the time. Any of you guys that watch my videos have seen this amplifier before. It runs a pair of vintage 6B4s here, 6SN7s, basically a Williamson design with the 6B4s, probably taken right out of one of the Acrosound transformer books. Uses a James output transformer. I have two of these guys. I'm only using one right now. Can't seem to find any good reason to build another stereo amp. And a power transformer uses a 5AR4 for a rectifier. Of course, I can plug in a 5U4 or a 5Y3 even, since it's so low power. But I thought I would show you guys just what I do sometimes in making measurements again on amplifiers that I've built at some stage in time. The volume was going up and down on my little stereo system. Well, it's actually not stereo, it's a mono system. I'll show you around here. It's right here. It sits right there. That empty spot's where the amplifier sits. And this is a little Mac tuner preamp up here. But this is where the problem is. And that's what I suspected. The volume is going up and down until it warms up. Once it warms up, after 5 to 10 minutes and everything's stable again, I said, well, which is it? Is it the amplifier or is it the tuner? Well, it turns out it's the tuner because this thing is as stable as a rock. But I thought I'd make some measurements and just have some discussion. I've been asked a number of questions lately about building amplifiers, and I'll give you my thoughts on it for what they're worth. They may be not the way you want to do it. Everybody has, I think, their own unique way of building amplifiers. But, for example, a question comes up, I think, about rectifiers. Well, you know, when it comes to rectifiers in maybe guitar amplifiers, not being a musician, I can't quite understand it, but I can understand it technically, that when you load the output, when you draw a lot more current, you get more voltage drop across your vacuum tube rectifier, and it's going to change the sound of your guitar amplifier. Now, in a stereo amplifier, I don't think you would want that, would you? You don't want when this drops, when the voltage, when the volume goes very high and you draw more current and you get more voltage drop across the rectifier, you get less voltage across your output tubes. And your power is going to significantly drop. Well, not significantly, but it's going to drop and the THD is going to rise. I've already made videos on that. Just on the line voltage, just the line voltage fluctuations can change THD measurements considerably. Well, so there you go. That's my thoughts on a vacuum tube rectifier in a playback, a stereo hi-fi type amplifier. It's probably best not to use it because solid state rectifiers have a constant voltage drop of about 0.7 volts, and they dissipate practically no power. I mean, this power is voltage times current. So if you got 0.7 volts across it at 200 milliamps, you can figure all that out. But if you've got 40-50 volts drop across this at that kind, then you can figure the power dissipated in this too. So there you go. Now let's make some measurements, and I find these measurements, as many times as I've made them, to be pretty interesting at times. Okay. First of all, we are running it right now at about 5 watts. Not a whole lot of power. The power into it is seen right here in this set of instruments. This is its power right here, 4.95 watts. I believe you can see that pretty good without me having to zoom in and out all the time. Let's look at T8. Let's get them all in there. THD's up here, 0.17%, and so on. Now when we get our oscilloscope running here, we can see that, I'll have to look at that a little bit closer. We can see that our era voltage down here is pretty minimal. There's our nice clean sine wave. This is on an old scope I have. I love this old scope. These old analog scopes are just great. So that's that. Keep the wires out of the way. So everything's looking pretty darn good. If we crank this thing up, we can get almost 10 watts out of it, below 1%. We watch the power, we'll watch it go up. Can we see the THD at the same time? No, we can't, so we have to change things here just a little bit. Now we can watch THD. Up here, it's 1.2% right up here. 9.89 watts. So anything below, just right below that, it dropped below 1%. There's 1% right there. 9.25 watts. Now, what does that look like over here? And here's something. Here's where I'm kind of going with this. Is all of these directly heated tubes, output tubes, you're going to have to end up with some sort of a circuit in the cathodes, in the filaments. The filament and the cathode, the same thing in here. And in my case, it happens to be this variable pot right here. I think it's 100 ohms that goes between the two. And there is a very, very fine balance point on this little pot right here that delivers the best power, the least amount of hum, the least amount of distortion. It all kind of comes together, all of these come together at one little very tiny point. And there's a couple of places we can see it. One of them is right here. This is that Spectra Plus software. I'm going to have to get in really kind of close to this so that you can actually see what's happening right there. Okay, I'm going to make this thing run and watch what happens. Now that's pretty impressive. There are a lot of spurs in there on each harmonic. Now if I crank the power down a little bit, see, things begin to look a little bit normal. Still a lot of spurs. But one of the things that I've noticed that balance between the two filaments has a lot to do with, well, one thing is, it stops right now. One thing is you can see the hum. You can adjust the hum. This is 60 hertz right here. Here's 120. You can adjust the hum with it. But these little spurs right here, the little tiny ones, just on to the left and to the right of the fundamental frequency. Watch when I'm going to turn that pot I was just showing you, and watch what happens. And it also affects. Okay, I'm going to turn it now. See how they go up? Whoops! See, they went way up. They go down. They go up. Like I'm swinging past a point of right there. Well, right there, almost right there. You can get it. That's pretty low. That took the vast majority of all of those spurs off. Whoops! I wish this thing would continue running, but it doesn't. It cleaned it up a lot. So I think a variable adjustment in the filament supply, which actually is grounding the filament, the cathode, and you're finding a sweet spot between the two, which is balancing the two tubes, and it greatly reduces these spurs to each side. Now they're not completely gone, and I don't think I can make them completely gone. And if I did make them completely gone, they would probably come back within 10 minutes of the aging of the tube. Well, the higher the power gets, they do start popping in there. Well, anyway, you can adjust these things until you're crazy, and it still doesn't do any good. Actually, it didn't do much for these out here, did it? So there are some, in the purest of sense, there are definitely some undesirable artifacts in these amplifiers that run directly heated cathodes, and I can almost guarantee you that's where all these spurs are coming from. If it were a more modern day amplifier running push-pull 5881s or 6L6s, KT80, whatever your choice is, you wouldn't see that. On the other hand, there's a strange thing about these little triode amplifiers that we seem to like. I do, at least. I actually like the way they sound. So that means I like the artifacts that the amplifier adds into the music. So the purest of music is apparently not appealing to us. Because I've seen amplifiers, and I bet you guys have too, made transistor amplifiers that look like the output of this Tektronix oscillator. They're so pure. And we don't like them. We just don't like the way they sound. They sound sterile or dead, or however you want to describe it. So it's taken me a lot of years. I've been doing this since I was a little kid. Of course, I didn't have this kind of equipment because I was a little kid. But I've always wondered why we like what we like, and it seems that the artifacts that a vacuum tube amplifier creates and adds into the music is something that appeals to us. Now, for whatever that's worth, I don't know, but there you go. Hope that came out good. Let's look at something else now. Okay, well, here are some thoughts that I've been asked for lately on building amplifiers. Now, these are just my thoughts, and your ideas can be considerably different or somewhat different, uniquely different to you. And of course, that's the beauty of building this stuff. What kind of output transformer should you use? Should you buy a new one? Should you buy a Hammond, a James, an old Acrosound, whatever? I'm just going to give you my experience for whatever it's worth. At one time, I had 6 Acrosound transformers. It's not this guy right here, but just assume it's an Acrosound transformer. I had 6 of them, and I built a stereo amplifier with it and made a bunch of postings about it. And all 6 of those Acrosound transformers, which were identical, performed differently, performed considerably different. I don't know if that's age, because they're all 50 to 60 years old. I don't know if it's quality control back in the day. They actually all performed quite well, but they all had little anomalies in them, and I had to deal with those anomalies different in each channel. And the way that I dealt with them was some ideas I got from an old Fisher amp called a Model 70A. Model 70A Fisher. Look it up sometime. The schematics of it are out there on the internet. And you can see how they put some capacitors like off from one of the screens to ground. And it helps stabilize it quite a bit. Okay, transformers. So do you get new ones or do you get vintage ones? Well, if you can get and afford new ones, that's probably a good idea. New ones are running the range of $150 in the 20-25 watt range. I think that's what these cost. I think a pair of these was like $240. Power transformer. Well, make sure your power transformer is big enough. That's basically it. You might want to. Sometime I did this also. Is you see how it's oriented? It's got this shield around it right here, and that is to reduce the external magnetic field of it. You have to be careful how you put the shield on there, because one time I wanted to put a shield on it, and I actually wound it. This is a stupid thing, and you'll all laugh at me because when you realize what I did, I actually wound this thing around the core. Well, as soon as I plugged it in, it just melted it right in two. And I said, "What in the world?" Well, I probably had a millivolt at 20,000 amps running through it or something, because I had a 1-loop turn around the primary. Well, I figured it out pretty quick. So, well, that's not going to work, is it? Anyway, it's got to go around like this. And you can add one with a copper strap. Anyway, so if your transformer is oriented this way, or if you turn it 90 degrees, it could induce a little bit more hum into your output transformer. So you want to think about that a little bit. Maybe keep it at a distance. Maybe not butt them right up against each other. Back to the rectifier. In a playback amplifier, except for the beauty of the tube, I can not imagine any possible good reason to use a vacuum tube rectifier. Whether you use triodes or the beam power tubes of 6L6s or the EL34s, whatever, that's personal choice. These driver tubes, these are 6SN7s. There's an older Williamson design that uses a 6SL7 and a 6SN7. The 6SL7 design is somewhat different, and it only takes about 100 millivolts to drive it to full output. I have built that amplifier more than once. It's pretty unstable. It's very easy to overdrive it. I do not like the way it performs. I much prefer the 26SN7s. Now Heathkit made a version of this. They made two versions of it actually. They're called a W5M. That's one of them. The W5M uses two 12AU7s. A 12AU7 is a medium gain triode. They call it medium mu. So are the 6SN7s. The 6SN7s and the 12AU7s are, for some reasonable purposes, the same thing. So you can use either one. I like the 6SN7s because they're easier to wire. You know, it gets pretty crowded in there sometimes with 12AU7s. But if you use a 6SL7 out here, it's got the same pin out as a 6SN7. The component values would be somewhat different. Or you use a 12AX7, you're probably going to have the gain of your amplifier so high that you just don't need much to drive it. This one takes about 2.5 volts to drive it to full output. And that's okay, to me. So that has a little bit of discussion of the high mu and the medium mu triodes, the two medium mu triodes, 6SN7, 12AU7s, vacuum tube or solid state rectifier. I mean, Macintosh went to solid state rectifier 60 years ago. Think about it. Whether you use triodes or modern day beam power tubes, these guys are not going to give you the analytical performance of the 6L6, for example. 6L6 is a hard tube to beat. But there's something charming about them, and I guess maybe we just viewed it there on those little spurs that it creates on each side of the fundamental and the harmonics. I don't know. As far as power input, it's a little bit more trouble, but I think it's darn sure worth it to put a removable power cord plug on it right here, because it's a pain moving this thing around with a you know, you got to get down to the wall outlet, or you got to unplug it from the back of your tuner preamp. So take the trouble to put in one of these. I can't remember the numbers of them. It doesn't really matter. You know what they are. This is a used chassis. As you can see, it has some mystery holes. There used to be something else. I don't know what it was. And for heaven's sakes, don't ever forget a fuse. Many years ago, back when I was about 20, I'm 68 now, so that was a long time ago. I remember building something and I said, what could go wrong? I don't need a fuse. Well, I built it, I turned it on in one room, and I left that room and I went out to eat. And I guess about 15 minutes later, when I walked back in to that room, from the ceiling all the way down to the top of the door was smoke. It had filled the room from ceiling to the top of the door with smoke because the transformer was smoking, because as soon as I turned it on, I didn't realize it, the little solid state diode shorted. Well, of course, my transformer was smoking and it was dripping goo out of it. So anyway, you know the end of that story. Had to start all over. So don't forget the fuse. Kind of a no-brainer, huh? Outputs, well, I use 4, 8, 16. I use this one just for a quick disconnect over to my speaker, so I can move this thing around and test it, work on it. Volume control input, you know, no big deal. Let's see, what is there interesting underneath it? Probably not too much. Probably only one thing that really catches my attention that I want to speak about. I do use chokes. I like chokes. I have found out over all the years that the one best and simplest way to reduce hum in the output of your amplifier is ground all of the power supply components at one point. That means the power supply filter capacitors, that means the center tap. Connect everything at one point. Everything in this amplifier that's grounded in the power supply. I hope this thing is completely discharged. I'm about to stick my finger in it. It's right there. I got those two jumpered together. If you can see that. That's where everything grounds. Not everything in the amplifier, but everything in the power supply grounds at one point to the chassis. And I don't have hum problems. I have had hum problems. Even if you so much as take a decoupling capacitor, you know how it goes through resistor stages to decouple the amplifier stages. If you take the negative side of a decoupling capacitor and ground it in some random point, you will probably increase the hum of your amplifier, and you won't like it, and you'll hear it, and you may not know why you did it or what's causing it. You don't have to ground everything in the amplifier to that point. You do not have to have a star ground or a bus ground. You can if you want to, that's a personal choice, but it is not necessary. If you look at the best of the best amplifiers out on the market, you will see that they don't go to that trouble. But they do keep their power supply components in one compartment of the amplifier. Like for example, the input of this amplifier is grounded right there. It's just grounded to the chassis. The cathodes and the cathode resistors of all the voltage amplifiers are grounded right at the sockets. They don't have to come back to this point. What else can I say? You probably always do want to use a grounded socket. In the old amplifier, sometimes where you plugged them in one way, you plugged them in the other would reduce hum, but in today's world of safety, I guess it's a good thing to always use a grounded socket. Here's something that I do. This is the bottom bell of the transformer. I take it off. I cut the hole in the chassis, put the transformer in, and with the holes and everything, and then I put the bottom bell back on the bottom of the transformer because it covers the hole and makes it look kind of nice. I like danger high voltage signs. They remind me. I put them there to keep me alive. To keep me from sticking my finger in there and making sure I did what I did a while ago. And because I do not like to get shocked. Not one tiny bit. Capacitors, I'm into the orange drop capacitors. I think they're as good as any. One of the things that I've learned here in the last number of years is if you order 10 of these capacitors, say you order 10 0.1 microfarad capacitors, and you start measuring them, odds are they're all going to come from the same batch, made at the same time, and I'll tell you what, pretty amazing. One is they're all going to measure pretty darn close, very, very close to 0.1. They're going to be very close to the component value that you ordered, and they're going to be even closer in value to each other. So matched components are really pretty easy to come by nowadays. There's really not much to do there. You know, the old electrolytic capacitors used to be like -5% to plus 100%. So if you ordered a 50 microfarad electrolytic capacitor back 50 years ago, it would say it would be anywhere, if it was -10 to plus 100, it'd be if the 50 microfarad would be anywhere between 40 microfarads and 100 microfarads, and that was okay. So you don't really have to get into anything really weird there. And if you do some modeling with LT Spice, you will find out that in your pi network, if you use a choke here, and you have a capacitor on the input and you have a capacitor on the output, got to turn the lights back on. Then you're using a pi network. You will find out that even with proper sized, I'll say, capacitors, especially the one on the input, the one right out of the power supply to the input of the choke, you will exceed the maximum rating of your capacitor voltage on turn on. And the larger that capacitor, the longer you will exceed it. I don't have it set up right now to show you that, but I guarantee you that's true. We've done some measurements, and other people have too, about turn on voltage, and you can see the voltage soar, and that's a pretty you know, right here and now type of a measurement to make with a voltmeter to see how the voltages will soar up on the capacitors before all the tubes warm up and load the power supply down. Well, if you model it with LT Spice, you will definitely see it there, and it's a lot more than you realize. So there's really no great advantage to making these capacitors these unearthly values. It doesn't gain you much. If you do the modeling, you will see, though, you actually will see that in the long run it does reduce the hum. But it is so insignificant that it doesn't matter. Once you get the hum, the signal to noise ratio down below about 75 dB, you can't hear it anyway. Even with super high efficiency speakers, I have Klipschorns. They are very efficient. You can hear, you can hear a fly cough out of those things if there's any hum in it. But once it gets down to about minus 75 dB, you don't hear anything. So what's the difference between 75 and 90? Well, except for what you can measure on your instruments, and it's really very, very hard to actually measure minus 90 dB SN, because everything comes into play. Whether it's sitting on a metal workbench, what kind of connectors you use to the input, everything starts to matter. But anyway, you can measure to about minus 80 dB pretty easily and consistently. So you're not gaining a whole lot by making these things. This is a 450 volt 100 microfarad. Making that a 470 microfarad capacitor isn't going to make this amplifier work one iota better than anything that you can measure here, in my opinion. Same thing with the capacitors. I don't know how much money you want to spend on capacitors, but these work quite well for me. And resistors, do you want carbon composition resistors, or do you want metal film? What do you want? The difference between them is almost immeasurable. I have measured them on a General Radio bridge, and below about 10 megahertz, I believe, they're ever so slightly inductive. I'm talking about nanohenries or picohenries. And then right above about 10 megahertz, they start becoming slightly capacitive, which is down into probably the fractions of a picofarad. So for audio, they have no significant reactance. I don't care if you use a carbon or metal film or whatever. Again, it's a personal choice, but you're not going to change much in your amplifier as far as its performance goes. Let's back off here and I'll show you something here. Here's a box of resistors I bought. I even wrote on it myself, check value, some way off. Well, this is some, you all know what these things look like. You go, wow, those are really nice. Brand new, never been used. New old stock, 1 ohm with a gold band, that means it's a 1 ohm resistor. Well, is it really? I'm not going to start measuring them here to show you, but these values are just generally way off. I'm sure they're a good 50 years old, so be really careful. I'm not saying don't use them, but when you get them, you better measure every one of them before you put it in there, because you're liable to put something in there you think is just Jim Dandy, and it is not. So that's some discussions of capacitors, coupling capacitors, electrolytic capacitors. The choke, the DC resistance of the choke is not terribly important. Probably going to be 100 to 200 ohms. It's not going to drop your voltage much. You will get a better power supply filtering with a choke, but you don't have to. You can actually put a resistor in here too, and it works pretty darn good. The measurements that I made, if my memory serves me well, is if you take this choke out and you put in a resistor at its value, the signal to noise will rise about 6 dB. But if the signal to noise ratio in this thing is, say, minus 75 and it rises 6 dB, well, now it's minus 69. That still isn't bad. So there you go. You want to put in a resistor, or you want to use a choke. Choke is a little bit better, but a resistor can work just fine too. Here's that balancing resistor I have right there. That's what connects. One side connects to one side of the filament. This connects to the other side of the filament. This one connects to ground. Actually, this one right here actually connects back through. I think you can see it here. Connects back through an RC circuit, the cathode bias resistor and capacitor. That's how I ground. That's how I developed the bias on it. It's cathode bias, it's not fixed bias. I've always been in a little bit of a quandary of grid stopper resistors. I understand that they can be of real value. I really can't comment a lot about a grid stopper. At one time I thought they were primarily used to stop the AM station detection when AM stations were just everywhere all over the United States. And that might have been one of their purposes, but I have some of my good friends trying to educate me a little bit more on the grid stoppers. I use 1K in here only because I guess it's just kind of the way it's done. I don't know any better. Sometimes I use them, sometimes I don't. I really don't see any difference. Maybe I'm missing something. If you guys know what I'm missing, then please inform us all. This is always a learning process for me. I think that's it right now. I'm going to stop for a moment and see if there's anything else I can think of. Okay, for the new comers that watch my videos, you guys that have seen many of my videos know all of this, but I'll go over it briefly for anybody that might be new. I'm going to have to hold the camera for this. I'll show you the test setup I have. These are a couple of very low inductive, they're called non-inductive, low inductive resistors. They're made by Arcol. They're 8 ohm, 1%. They have a very, very good temperature coefficient. That means that even when they get up to 400 degrees, they're still 8 ohms. You have to be very careful with these cheapy wire wound ones, because they will change dramatically as they get hot. They'll go down in resistance. These things are very stable. They're about $60 a piece, and I mounted them on a heat sink. I'll have a left and a right channel coming in, and this is the output, which goes to the test equipment, and I can switch between the left channel and the right channel right there. So what this cable right here does is goes over to this little breakout box. Everything in here is just completely connected together except for these two channels down here, which are compensated and attenuated to a 10x. But this is that same cable. The way I label my cable, see, I've got a yellow and a red. Well, that's the same thing at the other end. That's how I keep it with my cable ends, yellow and red, so I can find things. Otherwise, it's just a rat's nest, you know. So it comes into this box and it's feeding this box. So that means that everything else in this box is going out to a receive instrument. It's going out to the oscilloscope. It's going out to this meter. It's going out to the THD meter, the HP 8903, etc. It's going out to this oscilloscope over here. It's kind of interesting how it is. I see that blinking colors in the camera. The oscilloscope is not blinking. Well, I've never photographed this oscilloscope before, but anyway, such it is. This is a little Focusrite USB audio device down here. I feed the signal into it. Very much attenuated by this guy right here. You have to cut the signal down to a very, very small value here with some sort of attenuator so this doesn't turn red. If you overdrive it, it turns red. So can I do that? Yeah, I'll show you what I mean. Yeah, see there? It's overdriven, way overdriven now. So cut it way down. What this is doing is it's driving this computer right here, and I'm getting this display. That's what that does. So that gives me a FFT display of my audio signal. Very nice. Very nice thing to have. This instrument right here is a beautiful instrument. You can I've got it actually right now programmed to measure power. PO. That means it's 3.73 watts. The 8903 will do the same thing. If you take this number right here, which is voltage, 5.46 squared divided by 8, you get that number. Here is just a readout of the frequency. I like the ones that have a direct readout and not the ones that I have to have an exponent. You know, I don't want 1.00 times 10 to the third. I just want 1006. THD is right now 0.1%, etc. These are some RF instruments that don't play into this into this video. This is a signal generator. This is a spectrum analyzer for 50 ohm. And this is to measure 50 ohm power. This is a new oscilloscope I have. It's a 1 gigahertz 4-channel, magnificent scope. I apologize for it changing the colors like that. I don't know why it's doing that. But it's a, you know, auto set. It's wow, what a device. You know, these things back when they were new were almost $35,000. I got this one off of eBay for $550. Everything works on it great. It's marvelous. I can't believe we can have the things that we have these days. But anyway, that's it in a nutshell. That's my approach to amplifiers. I do like antennas. I build my own antennas, and I have an antenna wire coming in here. It's not that one right there, but I do have it coming in. It's actually coming in on 50 ohm coax. It's not 75, but it really doesn't make a hoot worth the difference. And I use this little Macintosh tuner up here, which does seem to have the problem of the volume going up and down, so I'm going to have to deal with that. Here's some older HP instruments that work very good. If you get these old instruments like this, you want to get them, if you can, with the original tubes in it, and assuming that they're still good, and they very well may be, these things perform amazing. THD on this thing I think is 0.02%. This is an instrument to measure inductance and capacitance. Does an excellent job, but then I build these jigs up here to measure inductance too, because I like to do that. You need attenuators. Here's a nice little attenuator up there, a 600 ohm. You need 600 ohms for audio. You need 50 ohms for RF in general. So that's about it. So I hope this is worth something possibly to the newcomer, to the new builder. Just some questions that's been running through my head lately from things I've been asked, and let's see how it turns out. Good constructive comments and discussions are always welcome. Thanks guys for watching.